What's up, my peeps? So, today I thought we could maybe do like a fun project that's really sort of outside the basics of golang. And I think an interesting problem to solve is creating an in-memory key value store where the value is compressed via gzip, and the communication layer that's handling the communication layer is WebSockets. So what's a WebSocket? A WebSocket is kind of like an HTTP connection, but upgraded in a way, and it's basically just a bidirectional streaming web protocol. So like one of the silliest but I think best analogies I ever heard for it was imagine that you're staying in a hotel and there's two rooms that are adjacent, right? So typically in a lot of hotels, you'll see like there's a door is shared between these two discrete rooms. And both people in both rooms have to agree to like open and close that door because there's locks on either side. Now there's also obviously a door that goes out into the hallway, but like a WebSocket is like that door that's between those adjacent hotel rooms. You can, as long as both people in both rooms agree, you can open that door and you can pass through bidirectionally, no problem, right? That's kind of like a WebSocket. So just think of it as like a streaming protocol, like gRPC streaming, something like that. But it's just a little different and interesting. So I don't know if there's going to be like a super practical application of this, but I think it's an interesting technology that I don't know a ton about. So I wanted to learn more about it, and I figured this would be a good way of doing it. So yeah, let's talk WebSocket in-memory key value database. So the first thing that you had to do was I had to go out and I had to fork Gorilla WebSocket, which is like the Golang WebSocket implementation. And I placed it in here inside of its own sort of like package, which I just called it WebSocket. There were some small changes that I have had to make, and there's some changes that I still have to make. So, for example, like I went to the Go 1.18, which in 1.18, any keyword is just an alias for the empty interface. I think it's a lot cleaner. So I went through and I made sure I just used sed and just went through all the files and just said, hey, anytime you see interface brackets, replace that with an any. There's also a place in here where it's doing the masking of the WebSocket call. It's using math rand instead of crypto rand. It's a security thing, so you typically always want to use crypto rand unless you're doing like testing and you're having to like generate dummy data basically. If you're doing anything security, always use, and you need to use random numbers, always use crypto rand. But yeah, so like I said, I went through here. Pretty much everything stands, like I said, just sort of the way that it is. What are some of the other things that I changed? That's pretty much it. I did get rid of the examples because it was a cyclical import, but I mean, the examples are going to be different because this is a different program that's just implementing the library and not, doing like the library itself. So I got rid of that. I moved a bunch of stuff. I still have to move like all the licensing and stuff over to there, but that's kind of outside like our purview of kind of what we're trying to do. So anyway, here's main. Very, very basic main. We haven't written any sort of functionality yet. This actually isn't going to look all that different compared to like implementing a normal HTTP server in Golang. That's one of the reasons I love the language. It just makes that kind of stuff like super simple. So what have we implemented here? Well, I implemented an upgrader. And what does an upgrader do? An upgrader, like I said, it upgrades parameters for upgrading an HTTP connection to a WebSocket connection. Now, obviously, we don't have any parameters in here. The upgrader does have a lot of options that you can set. Handshake timeout, a read buffer size, a write buffer pool, sub protocols, error functions, check origins, and enable compression as well. So you can compress things that sort of like as they're going over the wire. That's not something I'm probably going to cover right now, but we'll see. I think for how we're going to be designing this or how we're going to be doing this and just kind of keeping it simple, it's probably not something that we'll do. We'll do it on like the lib side, not necessarily the communication layer. So here's our cache. I shouldn't call this cache. This should be a database. You know, I don't know why I called it cache. There's no caching. It's not like really a cache, because like I think of a cache as like self-eliminating elements that are not frequently used, whereas keeping around elements that you do use. This is going to have functions of like insert, update, remove, and yeah, I think that's probably basically going to be it. So like I said, just keep it simple. And in which case, yeah, it's an in-memory key value database. So what is that key value database? Well, it's just a sync mutex and a map string of byte slices. So the keys are going to be strings, and the values associated with are going to be byte slices. So why byte slices? Well, remember I mentioned we're going to use gzip to compress data after it comes into our database. I'm calling it WSC. That's just what I'm calling the lib. Probably better names out there. I don't really care. I just call it WSC. And so, because it can be used as a cache, so I'm thinking like WebSocket cache. But let's just call this database, whatever. So this is pretty simple, right? So it's just a, print hi and log fatal, to listen and serve. And listen and serve is just, just creates a TCP network, and there you go. Life is grand. So yeah, let's start with trying to kind of build out like our main and see sort of like what happens. So okay, so just created a read-write mutex because I want to be able to both do read locking, which read locking is more efficient. So if you're not doing any kind of like data change within a single piece of functionality, just use a read lock. But I also need to be able to have those mute locks for inserts and deletes. One of our pieces of function is going to be like fetch values, right? So when I'm fetching a value, I'm just reading. I'm not necessarily I'm not changing anything about it. So that's when the read lock is going to be reused versus pretty much everything else, which is going to be using like just pure locking. So now we need to create, to me, like the first thing that you really want to do with this sort of stuff is just create an insert function. So I'm going to create a pointer receiver function that points to a specific cache, or a specific database, excuse me. And I need to change that. That's going to bother the hell out of me. And that function is just going to be insert. And the cool thing about this is that it doesn't have to be exported. It can just be internal. So let's do that. Okay, so what have I done here? Yeah, we have a pointer receiver function. The name of the function is insert. The function takes the arguments of an HTTP response writer and an HTTP request. Now we need to implement this in the main function, which, hey, like that makes things really, really super easy, right? So it's just and that's it. And our HTTP handler will log this functionality and it will handle it. Although right now it's not going to be terribly interesting, right? Like we're not really actually doing anything here. We're just saying, hey, try to connect, defer the close, and if there's an error, hey, we weren't able to upgrade the connection to a WebSocket. Something went bonkers, and we need to fix it. So that's kind of like our starting point for writing one of these insert functions. So now we actually want to do like something interesting. And the way to do this is to literally just do like a for loop, just like any other, pretty much like a long-running sort of Go routine. But yeah, we're gonna do it this way. So basically, what do we want to do here? Like, what kind of data are we actually digesting? So obviously we're going to be taking byte slices and we're going to be transforming them into some kind of like an object, right? And we want to be able to store that byte slice as well as the ID for that byte slice. And we want to be able to extract all that. So let's get started on that. Yeah. Okay, so what have we done here? So we just have a very simple for loop. It's just iterating over and over and over again. So anytime like a WebSocket thing, anything that connects to our WebSocket and connects particularly on this endpoint, it's going to instantiate this function. Basically, it's going to start it up and it's going to start spinning, and that's why we have a for loop. It's just going to keep reading until we tell it to stop reading. But the key is that this is the server. The client has to tell us that to stop reading. But there's some ways that we can do that here too. So what are we doing? We're just saying, hey, read the message. Now, read message actually returns three things. It returns a message type, a buffer, which is just a byte slice, and some kind of error. We're not going to be using the message type right now, but I mean that's like basically an enumeration. But anyway, yeah, we're just going to try to read it, and then we're creating a temporary structure of map string any, which means that we're just dumping stuff onto it. It's very, very fast because we're not doing any kind of like type inference. We will have to do type inference, but for only one piece of data. So we're just unmarshalling that, seeing kind of what happens, and if life is good, then we can keep continuing, and then we're just going to like print out the temporary structure. So this, I think, is a good point to like pause. I'm going to bust out a gist that I created that kind of like tests this with junky data that I just found online, and it'll just kind of like print it out. So yeah, let's see what happens. All right, so I have this gist up on my GitHub, but here you're just going to see it via like my NeoVim, which I hardly ever use, but whatever anymore. But VS Code is really, really good. Anyway, so yeah, this is just a bunch of like junk dummy data that I'm just going to say like, hey, this is the stuff that we're going to like expect. So we have to create some kind of like struct here that will like take these and like be able to like parse those appropriately, but like we can do that later. It's not really like that challenging. So here what we're going to do is we're just going to wait, and now we need to get our server here set up. So we're going to do go run main.go. Okay, cool. So we can see that that's running now. Let's try our thing here and see what happens. Oh, yeah. So here you can see I'm running the script right here. The script's running, and we're getting in all of this data. It's not being parsed. No types are being assigned or anything like that. It's just saying, hey, I'm outputting basically the byte slices. And then we can see here, like, we got a close, which is what we're looking for. So that's like a really, really good starting point. So let's look a little bit at like the script itself. So the script itself is here. We see auto-generated. Let's just ignore that for now. We can call it whatever we want. But then, yeah, we kind of have like our WebSocket dialers in here. And this is just like all kind of boilerplate stuff for connecting to a WebSocket. But here's kind of like the important thing. So we unmarshal all of our data into these structures. We create a bytes buffer. We have a new encoder that encodes it into some form of like acceptable JSON. And then we just write each message over and over and over again to the WebSocket until we eventually send a close message, right? Because remember, these two things are streaming. So it's going to keep reading until the messages until the server is told like, hey, close this, life is grand, we've received everything we want. Which here we can see like, hey, yeah, it's going to say message read error, but really we can switch on that message type, and that message type would say, oh, hey, if this is a message of type close, then we would want to get rid of that, which you can do. So like if I look here, like you can see here it has like a close message, right? So if I come in here and I say like WebSocket dot, you can see here like close message, which is of an untyped int 8, right? So if we receive an untyped integer of 8, we know that that's a closed message, which means we can just break the loop and we can shut down this thing internally, or we can also close it on like the other end. So if we don't necessarily want to close this, like the receiver, we can close the sender, aka the client, and not the server. But it kind of just depends on what you're trying to do. These Zevias have been hit and miss lately. Ugh, I don't know what's going on. That one tastes gross. I don't like any of these. This root beer is bad or something. Anyway. Alright, I'm back. I had lunch with fam. I went on my jog. And I'm ready to come back. So, where were we? We were ingesting our temporary struct and outputting that on the console, so we know that we're able to receive that thing, and it looks like we would pretty much expect. So remember that we're making a key value store, so we have to have the key Cool. So yeah, let's look at kind of what we did here. So this is remember here we are basically using a blank interface, and so here we're doing an interface type and whatever. We're doing a conversion here. We're basically a type assertion. Excuse me. We're asserting that this walks like a duck, quacks like a duck, aka it looks like a string, it works like a string, it does all the fun string behavior. And if that conversion fails, then we're also going to break out of this loop here. So the simple way to do it is just ask, hey, is it okay? If not okay, log and break. So we create a new bytes buffer off of the message. That's basically just so we can satisfy the IO reader-writer interface that we're going to need to use. And then we write to, we have a new writer to that message buffer using gzip. And then we create a byte slice that we want to dump our compressed data onto. And then we write we have our writer, which writes to that byte slice. Everything's gone well. We lock the data structure, the map string any. Or the map string, basically our database, our key value set, whatever. If it's, we basically ask if it's there, and if it's not there, then we set our new key, with the new key as the key, we set it equal to the compressed price, and then we unlock the database. Okay, my bad. I was doing something completely stupid. So yeah, anyway, you create a bytes buffer, you create a new writer to that bytes buffer, and then you write a byte slice to that. Duh. Can you tell it's been a long day? Anyway, we lock, see if it's found, output the buffer into a byte slice, which is what .bytes does on a byte buffer. And then we get, we'll output the key, and we'll output the length of the byte slice that's associated with it. Okay, let's give it a shot, shall we? So we do go run min go. Come here to my test script. And there you go. Cool. Perfect. So, I mean, that's the object that we're storing in our DB. So we basically have an insert function. Cool. Nice. Yeah, it works okay. So anyway, that's basically part one. And I think next, what are we going to do? Like basic CRUD operations. You know, we have an insert, a remove, an update. And I think that would probably do it. And then like some helper functions to be able to appear inside. But yeah, we'll see what happens. Talk to you later.